Hello guys, my name is Pittayut Naktaweewong. This is my project number 2 and we about second order circuit, and my question need to find IO plus VO plus DIO plus by dt dVO plus by dt and I infinity and V infinity, and this is my question. So my question give to the 12-volt source and 4 ohm resistor, 2 ohm resistor, and 0.25 inductor and the capacitor, and we have switch that is gonna open when time is greater than 0. So we start with the solution A first. In solution A, we need to apply DC analysis first for t less than 0. And when we apply DC analysis when t less than 0, so the inductors should be short circuit, and the capacitor it should be the open circuit. So it should draw like this. It should be like this. Oh, sorry. That's 4 ohm. That's 2 ohm. Right. And so we know that the I0 minus is equal to 12 divided by 4 plus 2, right? And we get 2 amp, and we know that VO minus is from 2 multiply I0 minus. So we get 2 multiplied by 2 and we get 4 volts. And we know that from the theorem that if the inductor and the capacitor can change abruptly, so I0 minus it should be equal to I0 plus. So we get 2 amp, and V0 minus it should be the same with V0 plus. So we get 4 volts, and that's the answer of solution A. So the next one is solution C. This is solution A. This is it, solution C. In solution C, we apply DC analysis again. But in this time, we apply DC analysis in for t greater than 0. So from this one, it should it should be like this. it should be like this because when t greater than 0, the switch is open. So we cut it out. And we know that this is open circuit. This gonna change to short circuit, and this gonna change to open circuit. So we get this one, and gonna finish it up. It says 4 ohm right there. That's arc, and it's 12 volts. And so that I infinity is equal to 0 amp because no current can flow here. No current can flow there, so we get 0 amp. And V infinity, it should be the most one, and the only one is 12 volts. So this is the solution from solution C. And the next one is B. So we need to find di 0 plus by dt and dv 0 plus by dt. So I copy this one again. So we didn't need to write it out again. Okay. So 5 okay. So how can we find di by dt and dv by dt? So from the theorem we know that the dv 0 plus by dt is from the theorem we know that c dv by dt equal to ic, so that dv by dt is equal to ic divided by c, right? So since the inductor current cannot change abruptly, so the inductor can be traced at a current source in this case. So I think I should draw it out first so that we can get it easily. It should look like this. Sorry. Still the same. This is still the same. T is 0 plus. And this is I. So in this case, IC, it should be the same with the I, because the inductor can be traced at a current source in this case. So IC is 2 amp. and so that we can easily find IC0 plus equal to I0 plus to M. Okay, so we know that dV 0 plus by dt equal to IC 0 plus divided by C. So is equal to 2m equal divided by 0.1 from the capacitor, and is equal to 20 volt per second. And this is the answer. And the next one is di 0 plus by dt. So we should read out it again in t equal to 0 plus 3 greater than 0, right? So I draw it again. It should be like this. I draw first, so can explain later. Okay, it should be no, confused. In this case, we know from theorem that LdI by dt equal to VL, so that di by dt is equal to VL by L. And since the capacitor voltage cannot change it abruptly, so the capacitor can be traced as a voltage source in this case. So as I draw it, this source, this capacitor, this voltage should be in this source too. So we get 4 volts. And we know that VC 0 plus is 4 volts, and what we gonna find is VL 0 plus, right? And to obtain VL 0 plus, we need to apply KVL for this. And so then we have minus 12 plus 4 multiplied by I0 plus VL 0 plus VC 0 plus. I forgot to write the VL here, so that we get same minus 12 plus by 4 multiplied by 2 plus VR0 plus VC's part is 4. Oh, I forgot there is equal to 0. So then we have VL 0 plus equal to 0 from this equation. And then we have di 0 plus by dt equal to VL 0 plus by L. From this one. So we get 0 divided by 0.25. That is equal to 0 m for m by second. So that's the answer of this question, and that's all of them is finished right now. So thank you so much. See ya.